Hello everyone. Welcome to the Solidity Fundamentals course. I am Anjali and I'll be your guide for this course. So in today's lesson, we are going to continue with our discussion on arrays. For today, we are going to discuss about two different types of arrays, which is the byte array and the string arrays. So as we've already discussed the fixed size arrays and dynamic arrays in our last class, so on the similar lines, we are going to discuss these two kinds of arrays, which is the bytes array and the strings array. So now we know that arrays in Solidity can be of fixed size, wherein you mention the length, the size of the array while declaring, and they can also be dynamic types where you do not mention the exact size because it's unpredictable at the time of writing the code. So there is a functionality by which you can extend the size of the array as much as you want. So we also learned that in this case, in the case of dynamic arrays, we use the methods like push, pop, and we use the length method in both the cases, whether it's fixed size or dynamic size, to check the length of the arrays. So now a little bit more about the byte array. So if you remember, we have discussed this in the value type data type as well. So when we were discussing the data types, I told you there are two types of data types. So a quick revision for both of them. One is the value type and the other is a reference type. So value types are those data types in which the values are stored directly at those data locations. So whenever Solidity assigns, whenever you, for example, you use an unsigned integer. So whenever you declare an unsigned integer, the value itself is stored in that unsigned integer. Physically also. But in case of reference type, what happens is the location which is defined for that variable, the physical location, the address of the data gets stored there, not the exact information. So you need not get much detail into this, just that value types would mean that the values are stored directly there. Reference type would mean that addresses are stored, reference to those addresses basically are stored there. Okay, so that's the difference between the two. Now, in byte array, what happens is there are two types. One is the fixed sized byte arrays, which can be, which are like further of many different versions, which we've already discussed. That is bytes 1, bytes 2, up to bytes 32. So that comes under value type data type because there the size of the byte array is fixed. If it's bytes 1, it will, fix 1 byte of space for you. If it's bytes 4, then 4 bytes of space will be reserved for that variable. So that's a fixed kind of byte array, and that comes under a value type data type. But if you talk about a dynamic byte array, which is represented by simply writing bytes, then that comes under a reference type byte arrays. This is one point of difference between the two. So we have fixed size byte arrays which can be represented as bytes 1, bytes 2, up to bytes 32. And the difference is that in this bytes array, which we have already covered, but like today we are going to note the differences between the two, and then we are going to write the code in Solidity in Remix IDE also to know the difference between them. So just a quick revision that in bytes fixed size byte arrays, which is bytes 1, 2, or 32, these byte arrays, if you once assign a value to them, you cannot access their index to change their value. So they are kind of immutable. So if you have assigned a value to this bytes array, it gets fixed. You cannot just, for example, in any regular array, which we have learned in the last lesson also, we could use the index value to change that value easily. So if there is an array of supposedly 5 elements, you can access the third element by using the index, since it starts from 0, so you will be using index 2 for the third element, and you can easily change that value. But in case of fixed size byte arrays, where the byte arrays of the size is fixed, you cannot change the value, it's immutable. Okay, but you can definitely check the length using the length method, that is possible. So the push and the pop methods are not applicable here. They were not applicable in fixed sized arrays, which we have learned in the last lesson. Same case applies here because this is a kind of fixed size byte arrays. So definitely length function can be used to check the length, but push and pop are only applicable to dynamic arrays where the array can grow as much as you want. Here the array cannot grow or shrink in size, that is fixed. So if it's 1 byte, it's 1. If bytes 2 is 2, then it's fixed. So you can just use this fixed space. Obviously, why would you use this? Because it will help you in gaps optimization. But most of the cases when you do not know what is going to be your size of the byte array which is required, you go for the other type, which is the dynamic array. So fixed size byte array is value type, as I've told you. Now comes under the second category of bytes array, which is the dynamic arrays. Now these dynamic arrays can hold any number of bytes, and here you can make use of the index. That's one important point of difference. In case of dynamic array, you can use the index to access or value, or you can change the value also, but that cannot happen in the fixed size case. So now you can appreciate why I call the fixed size byte array as the value type and the dynamic array as the reference type. Since fixed size byte array is a value type, so you know the value, you have assigned a particular value to it, so you can only keep that value. So you are not storing the address where you can point to it in case any change of value is there. But now dynamic array, what is it? It's a reference type data type. So in case of reference, you are just storing the addresses of the different data. So in case, even if you want to change the data, you only have to change that the other place where that address is stored, where that exact value is stored. So you're only storing the address, and that address can point to a different data now. So that is possible in case of dynamic array. That's why we say fixed size byte arrays are value types and they're immutable, but dynamic arrays are reference types, dynamic byte arrays, and you can use the index to change the value. Also, you can use, as it is possible with any regular arrays, you can use methods like push, pop, and length in case of dynamic arrays. And again, as I told you, these are reference type data types. So to avoid any confusion which may have occurred in your mind, you need to read these points one by one, and you need to, I think, apply them in the Remix IDE individually to see which functions works for which kinds, and to understand and appreciate the difference. We're going to do this in our this lesson also in a while, but for your own practice also, we can try making the same, we can try assigning the same data type to both the same test data to both the different arrays, and then we may try to check that. So we'll see this implementation in the Remix ID, but before that, we will also cover the second type of the arrays which we want to discuss today, and that is the string arrays. String arrays, or simply strings. So we have all, I think, if we have covered a programming language before, so we are all very familiar with strings. They are just another data type. But in Solidity, one thing to always remember is that string is a reference type data type. That means string basically stores the address or the data location of the data. Okay, so it is a dynamic array, but it has some unique constraints. Again, strings behave like dynamic arrays. Obviously, the length is not fixed. It can grow or shrink depending upon the values which you assign to the strings, but there are some unique constraints. Though the values can grow or shrink, but you cannot use index or those methods like push, pop, or length in case of strings directly. So now you must have realized that in the previous discussion, we just discussed the dynamic byte arrays, where we said that dynamic byte arrays can use index also, can use methods like push, pop, and length also to check the length, to push elements, or use the index to change values. All that is possible. But strings are some special case dynamic arrays wherein you cannot directly, you can not use these methods like push, pop, length. So what can you do? You have to convert these strings into bytes array, as we have discussed in the last slide. So the bytes dynamic array, you have to convert the strings to bytes array. If you do that, then all those functions which are applicable on the bytes array are applicable on the string as well. In string, those methods are not available, but in bytes array, the methods are available. So now let's go to the Remix IDE and check the implementation of bytes array as well as strings. So in our Remix IDE, I've written some code for checking these byte array and strings. So here you can see line number 5, I have declared a fixed size byte array using bytes 2. That means the size of the array will be 2 bytes. And I've given it the name as my fixed byte, and I've initialized it to AA. Similarly, I have used a dynamic byte array and I've initialized to AA, and the name is my dynamic byte. Okay. So moving downwards, you see I have written two functions over here, set value and push value. In set value, I am setting the value of the 0th index from A to B. Okay. Now I am doing it only for the dynamic byte array because it is not possible for fixed size array. I can show you this. So if I write my fixed byte and I try to access index 0 of this and I try to write B here, the moment I save this, so it gives me an error saying that single bytes in byte array cannot be modified. So let me remove this and now compile it to remove the error. So now again similar, we have this function called as push value, similar to the set value, but in the difference is that in push you append a variable in the end. So this is possible for dynamic byte array definitely, but not possible for fixed size array as we have seen in the previous case. So this is about fixed and dynamic size arrays. We are going to deploy the code and see the results for ourselves. But first let's see the strings part as well. So I've declared the string using the string keyword and I've made it public and I've given the name as mystr and we've initialized it to test. So this is a very simple format of declaring a string. But as I told you that in simple strings you cannot access the index of this. So since string is a dynamic array, so you may assume that all the functions which are applicable to dynamic array, for example index, like we have done here, so index access, or maybe we have used a push function to this dynamic array, all this should be applicable to string as well. But that's not possible directly. The way out here is in Solidity you can convert this string to a byte array and then you can use these functions. So how can we do that? Dynamic byte array, similar case as we have discussed previously. We will write bytes, then we will give it a name, and here equal to again bytes, and in bracket we will pass the string variable name which we want to convert. So mystr. Now if you see set string value, this string byte, this is my new byte array which I have created. I can access this value, index value here, and I can change the T to B. That is possible, but directly for string it would not have been possible. So if I write here mystr and I do 0 for here for example, and I try to write B here, then it will give me an error, and the error says that index access for string is not possible. So now let's remove this and let's compile our code and let's deploy it. The moment I deploy my code, you see, so now as you can see all the getter functions have been created by Remix ID. So in case I click on my fixed byte array, you see, so what is returned here is 0x6161. So as you can see, I declared AA, and in byte array I told you that all the representation is done through hex format, hexadecimal format. So this AA is stored as 0x6161. So let me explain you. 0x is for showing that it's a hexadecimal value. So 0x means the following digits are in hexadecimal. Now the hex value for A is 61, and again it's AA, so two 61s are stored in my fixed byte array. Similarly, in my dynamic byte array also we have double 61s, right? Now when you try to use this function set value, the moment I call set value function, I have replaced A with B. Now let me check the value of my dynamic array. You see it has become 62. That means A has changed to B. Similarly, if I call on push value function, let me click push value, and now if I again check the value, now you see a new variable, a new value has been added, 63, which is the hex value for C. So now value has changed to BAC because we have appended a value. All these things are possible only in dynamic arrays. So now in case of string also, if you see right now, if I check mystr, it is test. Now mystr is immutable, it will not change. But first of all, let's see what is the value of str byte. You see this is the same as test, but in the hex format. So T is changed to 74, E is changed to 65, depending upon the hex values of each letter. So we are storing it in the form of hexadecimal bytes. Now in case I want to call this function set string value, I am changing the first value which was test T 74. I am changing it to B, that is 62. So let me just call set string value, and now again when I call str byte, you see 74 has been replaced by 62, which means this is possible in case of byte array but not possible in case of strings. So that's it for today's lesson. See you in the next class.